Hi. If you are on LinkedIn or if you are on other social media, you are definitely hearing about new developments in AI ML field. And it's almost always overwhelming because the speed with which new happenings are coming out as news, it's so fast that you can barely catch up. So this lecture is like taking a step backwards and zooming out and seeing how the AI has developed over the past few decades. And we will split those developments or evolution into few different stages so that we can see what was the most prominent development at a given period and what is happening right now amidst all the noise. And in the next 5 years or something like that, what can you focus on so that you have the best possible career opportunities in AI ML? So something that has started with something as primitive as artificial neurons or multi-layer perceptrons, which is a feed-forward neural network. Something that started as simple as that now has reached to the stage of autonomous AI agents, which can take its own decisions and perform actions. So this lecture is an overview of what all things have happened in AI, what's happening around us right now, and what can we expect to happen in the near future. So we shall look at the developments happening in AI in 4 stages or 4 eras. The stage before 2010, where machine learning models or feature engineered models were most prominent. And that is truly the time when a lot of mathematical foundations were laid for basic probabilistic models or basic machine learning models. But then the true change and big career opportunity shift happened in the years from 2010 to 2020, when deep learning really exploded into the scene with deep neural network architecture enabling training vast amount of data set for actually performing useful things in production level environments. Then from 2020 to 2025, you can sort of call it as the era of foundation models. We have seen GPT 3.0 come out, and then later further models of GPT and other large language models, on top of which you can on top of which you can fine tune or perform retrieval augmented generation using a separate database and perform queries. And now in 2025, a lot of people are talking about AI agents. A lot of people are talking about model context protocol, MCP, and many other terminologies exist. So let's take a look at this whole development of AI in stages and try to project what to expect next, what kind of job opportunities might exist, and what could be the market size of artificial intelligence globally compared to what it is today and 10 years later. So let's have a look at the first stage, the before 2010 stage. And when I say before 2010, it can date all the way back till 1980s. So in the early stages of machine learning, it was more like a research topic of high interest to academicians. You could see a lot of professors working on building models like advanced versions of hidden Markov models or variants of support vector machines for performing classifications. So AI was not a household term before this time. Companies like IBM, they were trying to develop AI systems that can beat, like Gary Kasparov was beaten in a chess match that was in the 1990s, if I believe correctly. And all these things were happening, but AI models were still not primarily based in deep learning. They were still based in feature engineered model. So solving large scale problems using AI was still a challenge and still an impossibility. So during this time, there was also huge computational bottleneck. GPU based computation was still not a common practice. So people were trying to develop models where features are already available and they were using those features to perform classification or, let's say, regression. So hidden Markov models were used in speech recognition, although not with great success. Text classification was tried or attempted using support vector machines. And in computer vision, you might have seen images like this if you have spent some time in computer vision, where instead of allowing a deep convolutional neural network to learn the features through the process of training. Instead of that, we were using hand engineered filters like Sobel filter or Gaussian filter. There were various types of filters for purposes like edge detection, vertical edge detection, horizontal edge detection, or for blurring, or for extracting certain type of features. So all these things were involving significant amount of human manual effort because features had to be defined or kind of engineered by us. And if it's in the case of computer vision, the filters had to be hand engineered rather than letting the filters evolve itself through the process of training. That happened later. So this was the status of AI or machine learning in the years primarily before 2010. And it was also a time when there was probably not that many job opportunities in the AI ML space compared to what it was between 2010 to 2020, right? So there was logic driven decision making. You may have heard of artificial neural networks, fuzzy logic, genetic algorithm. So there were algorithms like this which tried to mimic intelligence in some way or the other, but you still had to do a lot of hand engineering, manual engineering of features. In 1980s, backpropagation algorithm was introduced, and this is one of the times when neural networks were reintroduced as a concept. Neural networks were already something that people had tried well before because in an attempt to mimic how the neurons work inside the human brain, so sort of like biomimetic neural networks. But it was truly revived in 1980s. But then there was also a period during 1990s or early 2000s when nothing much was happening in the neural network space, except for probably a few groups like Geoffrey Hinton, who won actually Nobel Prize in Physics for his work in neural networks. So there was a lot of these statistical models, probabilistic models, machine learning, feature engineered models like support vector machines, decision tree, random forest, HMM, hidden Markov models, or AdaBoost. And all these models started becoming prominent. And out of this, in my opinion, one of the best things that happened eventually was probably the development of something called XGBoost. XGBoost is an advanced version of random forest with boosting and bagging. And XGBoost is actually truly used in industry so much. So, and this is a variant of the simplest unit of this is a decision tree, right? So you use multiple decision trees and sort of use like a democratic process where you look at what each decision tree is predicting to make a global prediction. And that is the basic of random forest. And you can make random forest even better in the form of XGBoost. So this was one of the best things that came out of all these things that were happening in the feature engineered machine learning space. But the real problem was that if you had a lot of image-based data set, or if you had a lot of text-based data set, there was nothing much that you could do. Powerful GPUs were not in existence. GPUs were, of course, introduced, like graphic cards were being used for gaming, enhanced game experience. I remember using it back in 2008 or 7 for playing GTA San Andreas, GTA Vice City, these kinds of games. And but the usage of GPUs for AI, primarily for AI model training, that was very limited in scope. And if you looked career-wise, also most of the people in tech, they were gravitating towards software engineering more than AI ML careers. And that was also because there were very little production level applications of AI ML at that point of time, well before 2010. And then a huge shift happened starting from 2010 to 2020. And if you pinpoint one particular event, it was in 2012 when AlexNet was introduced. AlexNet was a deep convolutional neural network that completely changed the way people looked at deep neural networks for performing certain tasks. Although AlexNet was primarily used for image processing, it truly showed for the first time that you can have a large data set, you can have operations including ReLU activation function, drop out, and you can have deeper layers in the neural network for learning more complex features in your big data set. And AlexNet completely shattered all the records in the ImageNet competition, which was a competition for performing really well on ImageNet dataset. And AlexNet, I would say, truly opened the door to the revolution of machine learning and deep learning that we experience today. AlexNet paper was written by the first author, Alex, this person, then Geoffrey Hinton, who is the professor whom I mentioned, who won Nobel Prize in Physics in 2024, and Ilya Sutskever, who was the co-founder of OpenAI. And this paper on AlexNet, it has been cited more than 170,000 times. So this is a legendary paper which completely changed the way deep learning was being perceived by not just academia, but also by industry. And the AlexNet paper also demonstrated using GPU for enhanced or faster training process. So data was becoming abundant because of software systems, sensors, internet. Everything was making data more and more and more available. The only bottleneck was computing, and GPUs made the training part of neural networks or other deep learning models so much more efficient. So this is also probably the time when NVIDIA started seeing a huge growth in its sales. And earlier, while graphic cards were primarily meant for gaming systems, it completely shifted its use case for AI model development and training. So neural networks was a fascinating idea even before 2010, but the problem was to train and get something meaningful done using neural networks, you had to perform extensive training. For that, your computation was a limitation, data availability was a limitation, depth of the neural network was a limitation. But then AlexNet proved for the first time in the history of AI ML that deep neural networks can truly outperform hand-engineered traditional ML models by orders of magnitude. So this is the main change that happened in the year 2012. And then following AlexNet, a lot of changes happened. There was VGG introduced, ResNet was introduced, many variants of ResNet. And these papers are also cited many, many times, maybe tens of thousands of times. And all of these papers, on one hand, revolutionized computer vision. But parallelly, there were recurrent neural networks, LSTM, long short-term memory, etc., being developed in 2015 and around that time. And this on the other side, it propelled speech recognition or data of time series nature into a completely new level. And in 2014, generative adversarial networks were also developed. So generative adversarial network is where you have two networks. One is a generator, another is a discriminator. So let's say you want to create a fake image. Then what you can do is you train the generator to create an image. And so you start with a random noisy image, like noisy image, like noise grains like image. And then this generator will create an image, which is now fed as the input into this discriminator. This discriminator will try to predict whether this image is a real image or a fake image. And then if discriminator succeeds, then that feedback is given into the generator, and that prompts some change in the input image. And then not into the input image, it prompts some change into the weights and biases of the generator. And this will make some changes in the image generated by the generator. And finally, at some point, the generator will be able to generate images which are so real that discriminator won't be able to identify. There is actually a website called as thispersondoesnotexist.com. So these faces that you see are completely created using GAN, a variant of GAN. So each time if you refresh this website, you will see different faces coming. They are so real. The amount of details in their faces, in their eyes or in their hair strands, it's so unreal that you will never guess that this was an AI generated image. So this is very different from the diffusion models or more advanced models that are being used these days. But GANs are very, very good at specialized applications. So, and all these people are like fake people, like those people do not exist. And reinforcement learning was also propelling the growth of. So on one hand, there is supervised learning and unsupervised learning. And the third branch of AI ML could be considered as reinforcement learning. where you define an agent, you define an environment, and this agent interacts with the environment and receives a reward or sort of like punishment. And this prompts the agent to take action in a different way. And you can define various sort of like reward function to make the agent take exploratory steps in the current time step, or more like less exploration and more taking decision based on past experiences. So reinforcement learning has also propelled a lot of capabilities where AI can play games and beat like AlphaGo players. So Lee Sedol was, I think, the world champion. Lee Sedol. This was the world champion in AlphaGo, and he was beaten by an AI, and that was completely revolutionary. And you might have heard of news like people playing against AI in Dota games and getting AI beating those players, even the world champions. So all these things were happening, and the first starting point of all of this was AlexNet in 2012. So now, generalizing the capabilities of these models, if you look at what were the research hotspots, one was definitely image and video classification. You might have heard of models like YOLO, you only look once, for real-time identifying objects real-time from videos. Then language translation or language modeling themselves, generative capabilities, and then robotics and control using reinforcement learning. So a lot of my colleagues who entered into AI ML either entered through NLP, some people entered through computer vision, or some people entered into robotics field. So NLP, computer vision, and robotics were, from my experience, what I have seen among my friends and colleagues, the sort of career shifts that happened during the time 2010 to 2020. Amazon Robotics was also insanely hiring for their warehouse robots, for modeling their warehouse robots. And this was also happening during the time between 2017 to 2022. And a big part of all of these developments were these deep learning models. And industry also truly boomed, right? The roles like machine learning engineer roles that were being put out for, sometimes even including stock options, the salary was close to even $1 million often. And Facebook, like Meta, Google, Microsoft, Amazon, Baidu in China, they all began top tier ML research. They started publishing, they started appearing in top tier ML conferences like ICML, NeurIPS, etc. And AI was now truly getting productized. So Alexa, Siri, Google Translate, all of these became something sort of like a household terms after AI became so production level ready. And this could not have happened without the deep learning revolutions. And there were also like other recommendation systems like spam detection. All these spam detection was already existing in the form of, let's say, naive based classification, but now they are much more advanced and much more accurate. So all these developments were happening in the last decade or so. And even people who wanted to transition to AI ML from other fields like civil engineering or or mechanical engineering, basically people from non-computer science backgrounds, it was truly made possible. So many of my friends from mechanical engineering backgrounds, they are now at the end of their degree or masters. Now they are mostly into machine learning careers. So it's fascinating the way they made the transitions happen. Many of them I know had taken courses from MIT, X, Coursera, etc. for knowledge purpose, and also obviously from their own respective universities, they enrolled in AI ML courses, although their primary department was not computer science. So there was a huge democratization of AI education, and data scientist became like a very popular job title. And there were also people saying that data is now the new oil. In 1960s, 1970s, oil kind of propelled the growth of many countries. Similarly, then people were saying those who can process, analyze, and derive insights from data, they can now become so rich because data is now the new oil. So titles like deep learning engineer, AI researcher, ML engineer, AI engineer. All of these terms became very common, and all these jobs were exceptionally high paying jobs, sometimes much more than software engineering jobs. So while the years from maybe 1995 to 2012, 2015, it was a time for software engineers, people slowly started looking at opportunities within AI ML after 2010. So all these shifts happened in the second stage of AI that we discussed. Then the third stage of AI, we can say, happened rapidly in the last 5 years. So one funny thing to observe is when we talk about before 2010, we are looking at maybe 30-40 years before 2010 into one single bucket. Then when we look at the next bucket, we were looking at 2010 to 2020, almost 10 years. Now it has shrunk even more because so many things have even happened after 2023. So even bucketing 2020 to 2025 into one single category is not the right thing to do. But we can roughly think of this era as the era of foundation models. All of this started with the release of GPT-3 by OpenAI in 2020. It really changed everything. Although GPT as a term became a household term maybe after the release of ChatGPT in 2022, but GPT-3 itself was a very good model, unlike any other models until that point. With 175 billion parameters, it was truly a large language model, which could reason, which could write code, which could write poem, which could perform somewhat language translation. And all of these were emergent properties. The only singular goal that these models were trying to accomplish was next word prediction. And at the same time, the attention is all you need paper, which was released much before this, it also started becoming popular. More and more people started talking about what they understood by reading the attention is all you need paper, which introduced the transformer architecture in the shape that we see today. So these changes showed that you can achieve nearly human-like capabilities for these in natural language processing using large language models. And after GPT and other large language models, open source models were released, the model itself was not the major thing. It was what could you accomplish given a model? Could you perform a little bit of fine tuning, if not pre-training? Because pre-training is fairly expensive, but fine tuning is comparatively less expensive. So could you fine tune a pre-trained foundational model and accomplish what you want to accomplish with it? And transformer architecture and multimodal LLMs became very popular. Then Meta released Llama, which was an open source model. Falcon model was there. Then Mistral had their open source models. So once open source models started coming into the picture, that kind of eliminated the barrier for accessing GPT by paid subscription, right? So somebody could host this open source model in their server and you could access it. So Grok, you could access a lot of open source models using this grok.com website. So they also provide you API keys for accessing some of these open source models. So all of these things were happening in the years 2022, 2023. And this paper, I think attention is all you need paper now has huge number of citations. Last time I checked, it has now 180,000 citations, more than the number of citations for the AlexNet paper. And this was introduced in 2017. It's crazy, like how many times this paper is being talked about in various contexts. And this diagram also became so popular among people. This was the original transformer architecture introduced in the Attention is All You Need paper. So although when people started trying to understand transformer architecture in the beginning, this diagram and the equations that were mentioned in this paper were kind of difficult to understand. Now, a lot of things which are part of the LLM architecture has become so common that now many people consider this to be like a diagram taken for granted. But that was not the case maybe 3 years back. And if you look at the LLMs, GPT-3 came after that, GPT-4. Now we have GPT-4o. Anthropic Cloud had their own LLMs. Gemini, I think now there is Gemini 2.5 Pro, right? So this is, I think, the latest model, and that's by Google. Then Palm. So many large language models, open source as well as closed source, are coming. There are vision transformers, which claim to have better performance than convolutional neural networks for image processing, is coming. In fact, in one of our industry projects with our clients, when we performed our experiments we saw that for the data set that they provided us, vision transformer was working better than any of the best convolutional neural network models. And then we had image generation models through stable diffusion, DALI 2.0. I think we have DALI 3 also, right? Yeah, we have DALI 3 also now. And DALI, open source version of DALI was already available. I remember using DALI's open source version, I think into 2022. And now many people can access it through ChatGPT. OpenAI has basically the access to DALI. And we also saw like spaces like Hugging Face and tools like LangChain and terms like retrieval, augmented generation. These started becoming popular. So most of you may have heard of the term RAG-based chatbot, where you have a large language model that is already trained on a huge data set, but you have additional data set in the form of huge documents, and you can't pass these documents as part of the prompt directly, because then your context length will be exceeding. So what you do is you save your database as a vector database, and you kind of fetch whatever is needed from that vector database through similarity search, and then you append or you augment whatever extra information you have to pass into the LLM along with your prompt from your database, and then you get the result. So it's as if the LLM is having some knowledge about your database, although your database is was not part of the training or of pre-training of the LLM. Then there were efficient fine-tuning techniques, LoRa, Q-LoRa, etc. And all these terms, I don't want you to get kind of overwhelmed by seeing all these terms. I don't expect anyone to know all of these terms for sure, but it's more like just to give you an overview of, okay, these are all the different things that were being talked about by people in the community since 2022 onwards. Now the latest research focuses on alignment or non-alignment, where the goals of AI system and goals of humanity, they have to align for safety, AI safety. So alignment and safety of large models, including large language models. And there is an idea of memory and long context understanding. Basically, when you are interacting with a large language model, if you are starting a fresh chat, it has no context about who you are, or it has no prior information. It's as if you are starting from a clean slate. And when you use ChatGPT, you might have experienced this as a pain point, right? Especially when you want to start a new chat, but you want some context from some of the earlier chats to come along with in this new chat, but it's very painful to copy paste the entire context from some other chat. So you give the new context anyway separately by painstakingly typing it down. So memory and long context understanding is a research direction which aims at kind of personalizing the ability of LLM to chat with you by retaining the context. Then multimodal grounding, where you can not just connect the multi-model data, but also connect it with actions. And of course, AI agents, needless to say, this is probably by far the most popular term in 2025 in the context of AI, because AI agents can operate with various tools. It can operate along with LLMs. It can have access to APIs of some other softwares, and it can have ingest data, use LLM to kind of process the data, look at what the results are, and actually take decisions and perform actions. So AI agent is very different from large language model. Large language model gives you answers. It doesn't take any action, but agents perform an action. Example of an action is, let's say you are receiving a lot of emails, and some emails are priority, and you have to respond to those emails, and maybe the response can be crafted using LLM. But who decides which is a priority email and which is not a priority email? that decision comes as a result of an action, right? So maybe an AI email agent can do something like that. So this diagram had become very popular. Variants of this diagram where you have an environment and you have certain data from this environment which is fed into the agent or into the brain, which is LLM as input, and agent will look at and this LLM will be hosted in some server. Like if you look at LLM as GPT will be in its OpenAI server. Agent you may have hosted somewhere else, but agent will have API access, or agent will have access to the response from your LLM. Agent will also have access to other data set in your environment, and then maybe agent can take a decision. Okay, if the environment is cloudy, if it is if precipitation chance according to Google weather app is 90%, the action is okay. You carry the umbrella. Here is your umbrella. So this is like a primitive example, but there are many other actions that agents can perform. So there is a tool called Zapier. In Zapier, actually, you can define something called as Zaps, which is for process flow automation, like regular workflow automation, which does not include involve any intelligence. Like if you want to connect your Gmail with Google Sheets, where if a new email comes from a particular type of mail address, let's say you want to populate a Google Sheet automatically, then Zapier can do that. But that does not involve too much intelligence. It just involves a trigger, and that trigger enabling you to perform an action by having Zapier as the sort of like the middle person between Google Sheets and between Google Gmail. But now imagine you need some sort of intelligence to decide which email is important, which email is not important. Maybe Zapier should also have access to OpenAI's API, and this OpenAI's API is used to send that particular Gmail content into GPT, and then this email will be processed and it will say, okay, this looks like an important email, and then maybe a decision can be taken, and that decision can be then converted into an action in Google Sheets. So there are many tools which can perform actions. There are websites called like N8N, which is for building workflow automation, which includes agents. There is Crew AI. Yeah, this one where you can build agents, multiple agents that can interact with various other platforms. So all these changes, all these things are happening in industry level. All these things are also happening in research level in various organizations. And in my experience, or in my opinion also, AI agents is going to have huge impact because it will replace a lot of unnecessary repetitive human tasks. It will probably also replace some low-level intelligence requirement tasks. And this will bring massive productivity to many, many industries. And if you look at the career trend at the moment, there are prompt engineer roles. I mean, not like the prompt engineer roles which you see in some of these YouTube advertisements. Those are not the real prompt engineering roles that we are talking about in this context. But this is more like how exactly can you design a prompt which gets your task done, but also by taking constraints like context length, your cost of API call, all of those things into consideration. Then the RAG architects, this I have seen many companies are looking for people who can build RAG-based chatbots or general RAG architecture, retrieval augmented generation. And even with most of the industries that we have partnered with, what they were looking for as the first thing was a RAG-based chatbot. Then multimodality, like images, videos, sounds, and text. So multimodal capability. So developers who can build multimodal systems, and then AI integration engineers, people who can bring AI into the existing workflow. And finally, in many places like Europe, AI safety and compliance is a huge deal, and there are a lot of opportunities of high paid AI safety and compliance expert roles. This snapshot was taken from Geeks for Geeks, and it sort of enlists the top 10 highest paying AI jobs and careers. So this was 1 year ago in 2024, but you can just see the list: ML engineer, NLP engineer, data scientist, AI research scientist, AI software engineer, robotics engineer, business intelligence developer, data analyst, AI product manager, AI security specialist. So these are among the top 10 highest paying jobs in 2024, and hopefully will continue to be so even in this year or next year. And now let's look at the last fourth era that we are talking about from 2025 onwards. It's very hard to predict exactly what will be there even next year. That is the truth, but we are just trying to wishfully forecast and see where the opportunities for us may be lying ahead. So if you look at 2010 to 2020, it was a time when predictions were a big deal. After that, it was a time for generative AI. So, but now it's no longer just about predicting or generating some stuff using AI, but it's more about performing actions using agents or adapting to the new needs of humans. And then if AI itself can evolve to perform new actions or new capabilities by some kind of agentic framework, that will have a lot of value. So if you look at the evolution of AI in today's time, right now, autonomous agents have a huge scope. And I know that everybody is talking about this, and there are many companies. There is a company called Manus, and they have, I think, raised 75 million or something for building AI agent. Just check their landing page. They have a free version. I have used their mobile app as well as their desktop like web app. It's a fairly nice AI agent for performing many type of tasks. And there could be specialized LLMs for healthcare. So right now LLMs are trained on the entire data and on internet, but maybe there are LLMs that can do specific tasks in maybe architecture, finance, medicine, or engineering with very high domain specific capability. Then multimodal cognition. So large language models originally were mostly text based, and then there were multimodal LLMs. And so now if we can have vision capability, text, speech, motion from some sort of sensors or cameras, and generally sensing things from the environment and incorporating that into the data set and processing that and deriving intelligent insights. So those things are about to come. And then the next one is very fascinating, the fourth one, AI combined with any given field. So there is a evolving field called scientific machine learning, where the goal is to combine any traditional domain of science or engineering with machine learning or with AI. So biology with AI, chemistry with AI, physics plus AI, astrophysics with AI. And this is something that we also work on extensively. And it's a booming field, it's an upcoming field, but it will have a lot of scope for even people who are hardcore physicists or hardcore biologists to bring AI into their domain rather than dropping what they are doing and going into AI. So this will kind of democratize AI's permeation into almost every single field. Then there is edge computing and AI privacy concerns, where instead of having models run on some other servers, what if the model can run on your phone? So there are locally executable or locally servable models. There are small language models. There are concepts like 1-bit LLM. Although none of these are really at a production level where I can have a sort of like a small language model running on my phone. It is probably not there as a production level, industry level thing, but it is going to happen sometime soon. And then last idea, causal reasoning and simulation. So you might have heard of reasoning based LLMs. We in fact have an entire course on reasoning based LLM on our YouTube playlist. You can check it out. But basically LLMs that can understand cause and effect relationships can learn almost like how a child can learn by observing the environment and understanding, oh, this resulted in that, and this capability of understanding cause and effect correlation or relationship will hopefully give almost human like intelligence to these models. And there are several different breakthroughs that people are expecting. I mean, these are just pure speculations, right? And there is no guarantee that any of this will happen. But memory-based LLM, which I mentioned, LLMs currently do not hold the context of your past chats unless you are following the same chat. The context window is very limited, but memory-based LLM somehow can personalize your experience of using an LLM, so that your particular LLM will have the entire context of who you are and how it should respond to you. Then along with reasoning models, self-reflective models, goal conditioned models, which will change the way it is reasoning on the go, depending on where it is supposed to go based on a goal. Then quantum computing is becoming very popular. You might have heard of the news of Majorana chips by Microsoft being released. This was a few months ago, Majorana 1. This was a quantum chip, and quantum computing, although it's in its stage of infancy right now, it can hopefully perform very specific tasks for machine learning for very, very ultra specific applications. Then like a huge swarm of agentic systems where there are small AI agents performing small dedicated tasks, and this entire system of agents holding an entire huge company's entire workflow, perhaps, or delivering a unparalleled customer experience when they are using a product. And this product is itself is consisting of dozens of agents doing dozens of tasks or hundreds of tasks. So hopefully all these things might come into not just a research level breakthrough, but actually production level industrial breakthrough. And if you look at the upcoming AI careers, there could be AI system designers. Let's say you are running a company and you are looking for an expert who would like to integrate AI into your workflow, internal workflow, as well as customer facing aspects. You might be looking for AI system designers who take various aspects like cost, efficiency, everything into consideration. Then there will be huge demand for AI plus X experts. AI plus X meaning people who can combine AI with any other field, with domains in science, which can perform maybe accelerated drug discovery, accelerated material discovery, etc. Then there will be a scope for something called as alignment researchers. Alignment as in whether the goals of AI and goals of humanity, they align together, because as we perhaps move closer and closer to artificial general intelligence, this is a huge concern. Alignment has to be there between AI systems and what humans are looking for. And there are interesting roles like human AI collaboration architects. So previously there were human computer interface engineers, HCI engineers, and maybe now there is a new evolution of human AI collaboration architects, and of course agents engineers. So this is by far the thing that I am personally looking forward to the most, because there are many tasks that I am looking to automate with the help of AI agents. And if there are production level tools which can be used outright with minimum friction, I can really adopt it into my own workflow to make my life better. So AI agents or agentic engineers, these are roles that I'm pretty sure will have huge impact or huge career impact in the upcoming years. And I think it's a good time to wrap up this lecture with just this one graph. You can see the market cap growth. I think the compound annual growth rate, it's mentioned here, it's 30% compound annual growth rate of AI market. So look at how the market cap looks like in 2025, around 400 billion, and it's hopefully will be reaching almost 10x in the next 10 years to perhaps 3.54 billion. So there is no doubt that AI is growing rapidly, and the opportunities in AI is also going to increase rapidly. Will AI take away a lot of jobs? Yeah, it's very likely. Many jobs which probably does not require too much human intelligence will be taken away by AI. But that was already happening. Like Zapier took away a lot of, it automated a lot of processes which were probably done by humans before. So it was already happening, but nobody called these simple repetitive process automation as AI taking away jobs. But now that intelligence is also coming into the picture, people are getting more paranoid that whether their job will be relevant or not. But my personal take is that whatever it is, try to learn AI as a skill. It is almost like a literacy of this current age. So becoming AI literate is a very, very important thing for advancing the humanity and also for your own career growth. But this lecture hopefully brought a lot of clarity into the big picture aspects of AI. My intention was not to give you like a roadmap or anything. I did not tell you what to do or anything like that, but it was to kind of lay how AI evolved from maybe 40, 50 years ago till now and into the future. So with that, we can wrap up this lecture. Thank you so much for listening. We'll meet again in another lecture. See you until then. Bye.